All
You're
right.
doing it.
I'm fixing them. You're gonna ruin them.
All right, so we all have the design of titration. So essentially what we're doing is going backwards here. And let's take a look at this up close and personal. What do we have here? Let's look at the wordage here. Design a titration that will reach an equivalence point when 30.0 milliliters of 0.15 molar NaOH is added to HF. Now, it's really sometimes important to write what's happening, because sometimes you don't know what's in the burette and what's in the beaker. Okay? Sometimes I'll use verbiage. Now, I'm adding this to HF. So I've got myself a beaker. Okay? And sometimes it's really helpful to just draw a simple diagram. So there's my beaker. Okay? And in my beaker, okay, I'm going to have HF. And now we should know from table L, HF is a what? Because you'll have table L. Is HF a strong acid?
Yes.
Or a weak acid? Okay, if you don't know, you'll have table L with KAs that tell you, you're right, it's weak. Okay? Now, what are they telling me? Okay? They're just telling me I have 20 milliliters in my beaker. Hey, you notice something? They didn't give me what? They didn't give me the molarity. So what do we do with titrations? Titrations help us determine what the concentration of something unknown using some standard information. So guess what? I've got a burette. It doesn't have to be a burette, but that's a pretty thick burette there. All right. But what I have in that burette, okay, is that I have NaOH. And we should know NaOH is a strong base. Okay? And we know its concentration. We have to. 0.15 molar. And we know that we needed 30 milliliters was added total. Okay? So 30 milliliters was added. Does that tell me that we're at the equivalence point? But they said what? Okay? Was that the equivalence point?
Yeah.
Okay, so they're telling me that we added 30 to get to the equivalence point. Okay? So, just from that information alone, we should be able to start with our graph. Okay? So by knowing it took 30 milliliters, and by the way, what's the verbiage here? We are titrating in the beaker HF with a strong base. We are titrating a weak acid with a strong base. That's the verbiage here. Okay? Because maybe that's how I'm going to say it. Maybe that's how they're going to write it. Okay? So that's important. Now, what do I know? They said that 30 milliliters of the 0.5 molar would reach the equivalence point. That's really important right there. So I'm going to highlight that. So equivalence point. So I know 30 milliliters got me to the equivalence volume. So in my graph, a couple things I'm going to write to keep myself straight, to understand what's going on, is number one, is that this is going to be volume of OH, strong base, added. So I don't get confused. And what do I know? 30 milliliters. On this 30 milliliters somewhere is going to be my equivalence point. Now I can't finish a point on a graph without the what? X
And the Y.
and the Y. All right? So here's what I do know. I do know that this is a weak acid. And I do know that this weak acid, okay, is not going to dissociate very well. But we're going to help it along because we're adding a what? Strong base. We're forcing it. And when we force it forward stoichiometrically, we're going to make, of course, water. Okay, because, of course, the H plus is going there. But more importantly, we're making a conjugate base. There's my A negative. There's my A. And that conjugate base, because this is a weak acid, this is a relatively stronger conjugate base. So that F negative will ionize water. It will pull. Fluorine is small, very electronegative. It's going to yank an H off of water, and it's going to form, okay, HF, reform the acid. That's why it's a weak acid, and it's going to produce hydroxide. So party people, okay? first thing I'm thinking of is, where do you think that pH is going to be? Do you think it's going to be above 7, below 7, or on 7? Above 7. Every time a weak acid is titrated with a strong base, we're going to have a conjugate base that can react with water to form hydroxides. So it's going to be above 7. Now, we cannot calculate that pH right now, okay? Because we will need equilibrium to do that problem. So right now we can't do that, so it's going to be an estimate, okay? So that one's an estimate. So knowing that this is 5, 6, 7, this being 8, 9, and 10, okay, we know it's above 7. So we're going to estimate that point, okay, and we will calculate that point later in the year. So I'm going to put it above 7. That's an estimation. You're going to do this again in the springtime with everything but the addition. You'll be like, oh my gosh, some of this makes sense to me now. Okay? So we're going to estimate. That's an estimate. Okay? But that is, of course, my equivalence point. Do we and again, you couldn't estimate that, okay, on your lab. You just identified it. Okay. Now, what else do we have to estimate?
Starting.
Correct. We're starting with HF. Because it doesn't completely dissociate, I don't know how much free HFs or free H pluses there are. The moles of HF are not the moles of H pluses because it's a weak acid. It barely goes forward. Sitting in water, this is not happening. Sitting in water, it's barely going forward. It's a different reaction, correct? So I need equilibrium problem to figure out. Using its Ka, I could calculate how far it goes forward and get a pH, but that's for the springtime. So I know it's a weak acid. So I know I'm not going to start where? Really, really low. I'm going to estimate, okay, a little higher. This is a guess. So I'm going to start here. That's total an estimate. But if I started really, really low, I could take off for that. Okay, do not start really low. Remember, when we had a strong acid, strong base titration, did we start low? Because we started low, we had a tremendous asymptote. Our asymptote's not going to be what? As high because we're starting high. Okay, those two are the 2 points I'm estimating. Now, you should be able to calculate the other points. Well, hello, if I have 30 milliliters of base added to equivalence, I know what my half equivalence point is, don't I? 15. I guess that'd be right here. Okay? I couldn't do a graph where so, no, 1, 2, 3, 4, yeah, I had to do that. Yep. Okay, so this is my half equivalence point, and I'm going to change the color because I want to make sure that we know that these are not estimates. So we're going to go to brick red. Feel like I know the difference. The crayon has like so many reds, and they all look the same to me. Okay, so that's like a pretty terrible line, but I know it's going to be between these two, isn't it? Okay, this one I'm not going to estimate. This one will be a point that you'd have to give me. Okay, now, they didn't give me any information, but I know it's HF. HF, sitting in water, is barely going to go forward. But it will produce some of these H3O pluses, and it'll produce some of these. Not very much. Okay? And this is liquid. It's got a Ka. In order to solve that point, I got a K. What was the reverse? What did you guys do? Didn't you actually figure it out, this point, by having the curve already? And didn't you use this to get you the Ka? Well, to make the point, I got to start with the Ka. Someone look up for the Ka of HF. Go to table L for me and go find it. You would need to go find it.
3.5 times 10 to the negative 4.
So what's the Ka?
3.5 times 10 to the negative 4.
Okay. 3.5 times 10 to the negative 4. What does that mean, party people? Who's favored? It's a small number. Who's favored? Okay, yeah. The HF, the undissociated acid. Because what is equilibrium? Products over reactants. Small number less than 1, my denominator is bigger, which is my reactants. It barely goes forward. All right. Well, all I got to do is make that a pKa And wouldn't that equal my pH at the half equivalence point? So what does little p mean?
10 to the negative.
Right, so do the what?
Or log.
So negative log of 3.5 times 10 to the negative 4, and that's going to give you your pKa. So let's do that, party people. Negative log 3.5, I would use the second function EE key, negative pho. And I get, party people, the pKa is equal to 3.46. We can round that because we're estimating 3.5. And wait a minute, doesn't that equal the pH at the half equivalence point?
Yes.
We're learning this forward and backwards. So party people, this would be a point I would grade. I'd expect you to figure out that half of 30 is 15. I'd expect you to know that by finding the Ka, giving me the pKa will equal the pH at the half equivalence point. So the half equivalence point is 3.5. So this is 3, this is 4, and this is now my pernt. Now I'm going to make an adjustment to my other point. Because shouldn't this be a little lower?
Yeah.
We were guessing. Sorry, I feel bad. People are like, well, I can't erase that. Well, I have some white up.
I have a pencil. Going down to 2.5.
So yeah, so we're going to start in this range here. Who knows? We're guesstimating that. Clearly, this has to be lower than its Ka. Why? Based on everything I taught you, why would this have to be lower than the half equivalence?
You have to have a buffer.
The buffer, right? At this position here, you have a lot more what? HF than conjugate base. We're adding more so it's going to go up a little bit. Right? Correct. pH equals what? pKa plus the ratio, right? You have to know that this position, there's more HA than A negative. Okay? Cool beans. We're almost done. The last point, because remember, the only points that I can do is what? I'm estimating the pH. I know it's 0. I'm estimating the pH at equivalence, but I better know it's above 7. But I'm not estimating the volume. Okay, good, right? Now, another point I definitely know is final pH. Because what am I adding? A strong what? Base. And the final pH is the excess, beyond. Think about, party people, what I've been teaching you for the last month. Limiting reagents, right? The limiting reagent is right here. They're both limiting. And then I start having an excess chemical. Well, who was I adding? Right? I was adding base to acid. I was titrating a what? A weak acid with a strong base. So, what you do is, now let's assume, we have this, I don't know if I said it here. Oh yeah, I did. Plot all possible points, even ones you can only estimate. Show all work for each point. Sketch the curve below if 50 milliliters of base was added. So 50 milliliters was added. So party people, this is equivalence. And so from here to here is how much excess? 30 milliliters of my base got neutralized by the acid. No more base at this point. But we kept going. Well, there's no more, HF is gone. So we just kept, we have extra what? Base. So this is the excess. Hydroxides. And how much? 30 minus 50, you have 20 or 0.020 liters. Hey.
Doesn't it say that you're adding 50 milliliters of base though, so would that be 70 milliliters of solution?
Yeah, we haven't gotten there yet. Okay? Right now, as I want to know, because to get the pH, I need the H plus concentration. To get the H plus concentration, I'm going to get the hydroxide concentration because they're equal, right? So you're right, I need the total. But right now, I need the moles of base that was added, the moles of hydroxide that was added. When we get to this point here, the equivalence point way up there, okay, all the hydroxide was eaten up by the HF. But now we have excess. So I'm trying to find the moles of what? OH. And we had 20 milliliters that was dropped extra from 0.15. So I'm going to find the total moles of hydroxides that were added in excess. Okay, so 0.02 times 0.15, and so that gives me 0.003 moles of excess hydroxide. Cool. I want the concentration. The concentration of the hydroxide, I can get a pOH, can't I? Subtract from what? 14, I get the pH, and I'm booyah, done. You see how this is connecting? Hopefully. Okay? So, this divided by, and that's right, Jason's absolutely right. I cannot divide by 50 or 20. Right now, I added 50. This is the volume. I added 50 total milliliters to my beaker that started out with 20. So I have a total of 70 milliliters. 0.07 because we're talking with what? We're talking about, it has to be in liters molarity. So 0.03 divided by 0.07, 0.003 divided by 0.07 gives me a molarity to be 0.0429er, and that's the what? That's equal to the concentration, brackets, hydroxide. I'm going to write it all here. That represents molarity of the hydroxide ion. Hey, you could do this two ways, and I don't want to keep shutting you out because some people like it this way. What do we know? We know that the H plus times the hydroxide concentration equals what? 10 to the negative 14. So there might be someone who says, I see it this way. I got the concentration of this. Couldn't I solve for this and do negative log to get pH? Sure. I'm not a big fan of that. I've got the OH. I'm going to find the pOH. So I'm going to do negative log of that, my second answer. Close my parentheses. And I get a pOH to be
1.3.
negative log. I got my pOH to equal 1.376. How do I get my pH?
14.
Subtract from 14. And so my pH,
12.6.
my final pH, 12.6. And so party people, that's a point that would be graded. So this is 11, 12.6, something like this. And now we're going to draw our curves. Ooh, what color should I go with?
Brown. You use brown enough.
I'm going to go with orange.
Okay.
We're going to come up. We're going to keep coming up. Oh, we got an asymptote. Oh! Middle of my asymptote, and then I'm gonna level off. Booyah. I would not grade. As long as this point was below your half equivalent, it's good enough for me. I would not grade exactly where this is, except it better be above 7. I would definitely grade X and Y for this point because your Ka should be able to give you this. And I would definitely grade the pH of this point. Okay? We will finish this in the springtime by figuring out the exact pHs for those because we need equilibrium. All right, so if you saw that, great. And we worked backwards, which means we were working forwards. And hopefully you see how this is interconnecting. And that's how I need you to understand this. So that's a good little activity. So I'm done today with the exception of you guys can start the homework, okay? Or finish the lab or anything like that. All right? So hopefully you saw some connections with this.